Welcome to my presentation on domain of a function. So what is the domain? The domain of a function, you'll often hear it combined with domain and range. But the domain of a function is just what values can I put into a function and get a valid output. So let's start with some example. Let's say, let me make sure my pen is all set up. Let's say I had, wrong color. Let's see, pick a nice color. Okay. Let's say I had f of x is equal to let's say x squared. So let me ask you a question. What values of x can I put in here so I get a valid answer for x squared? Well, I can really put anything in here, right? Any real number. So here I'll say that the domain is the set of x's such that x is a member of the real numbers. This is just a fancy way of saying that, okay, this R with this kind of double backbone here, that just means real numbers. And I think you're familiar with real numbers now. That's pretty much every number outside of the complex numbers. And if you don't know what complex numbers are, that's fine. You probably won't need to know it right now. But real numbers are every number that most people are familiar with, including irrational numbers, including transcendental numbers, including fractions. Every number is a real number. So the domain here is x. X just has to be a member of the real numbers. And this little backwards looking e or something, this just means x is a member of the real numbers. So let's do another one. A slight variation. Somehow my circle tool got changed. Let's see. Okay. So let's say I had f of x is equal to 1 over x squared. So is it the same thing now? Can I still put any x value in here and get a reasonable answer? Well, what's f of 0? Let's see. Oh, something happened to my pen. Let's see. Oh, what happened to my pen? Let's see. F of 0 is equal to 1 over 0. And what's 1 over 0? Well, I don't know what it is, so this is undefined. Undefined. No one ever took the trouble to define what 1 over 0 should be. And they probably didn't do it. So some people probably thought about what it should be, but they probably couldn't find out with a good definition for 1 over 0 that's consistent with the rest of mathematics. So 1 over 0 stays undefined. So f of 0 is undefined. So we can't put 0 in and get a valid answer for f of 0. So here we say the domain is equal to the little brackets that shows kind of the set of what x's apply. That's those little curly brackets. I didn't draw it that well. X is a member of the real numbers still, such that x does not equal 0. So here I just made a slight variation on what I had before. Before we said for when f of x is equal to x squared that x is just any real number. Now we're saying that x is any real number except for 0. This is just a fancy way of saying it. And then these curly brackets just mean a set. Let's do a couple of more ones. Let's say f of x is equal, my pen is, I have to find a better way. Let's see, is equal to the square root of x minus 3. So just, up here we said, well, this function isn't defined when we get a 0 in the denominator. Well, what's interesting about this function? Can we take a square root of a negative number? Well, until we learn about imaginary and complex numbers, we can't. So here we say, well, any x is valid here except for the x's that make this expression under the radical sign negative. So we have to say that x minus 3 has to be greater than or equal to 0, right? Because you could have the square root of 0. That's fine. It's just 0. So x has to be greater than or equal. X minus 3 has to be greater than or equal to 0. So x has to be greater than or equal to 3. So here our domain is, let me make sure I have enough space. X is a member of the real numbers such that x is greater than or equal to 3. Bam. Let's do a slightly more difficult one. What if I said f of x f of x is equal to the square root of the absolute value of x minus 3. So now it's getting a little bit more complicated. Well, just like this time around, this expression under the radical still has to be greater than or equal to 0. So we can just say that the absolute value of x minus 3 is greater than or equal to 0. So we have the absolute value of x has to be greater than or equal to 3. And in order for the absolute value of something to be greater than or equal to something, that means that that means that x has to be less than or equal to negative 3, or x has to be greater than or equal to 3. Right? It makes sense because x can't be negative 2, right? Because negative 2 has an absolute value less than 3. So x has to be less than negative 3. It has to be further in the negative direction than negative 3, or it has to be further in the positive direction than positive 3. So once again, x has to be less than negative 3, or x has to be greater than 3. So we have our domain. So we have it is x is a member of the reals. Such that, actually, I always forget it. Such that the line, I forget. It's either a colon or a line. I'm rusty. It's been years since I've done this kind of stuff. But anyway, I think you get the point. It could be any real number here as long as x is less than negative 3, less than or equal to negative 3, or x is greater than or equal to 3. Well, let me ask you a question now. What if instead of this it was, oh, my pen. Let's say instead of this, that was the denominator. So this is all a separate problem up here. So now we have 1 over the square root of the absolute value of x minus 3. So now how does this change the situation? So now not only does this expression in the denominator, not only does this have to be greater than or equal to 0, can it be 0 anymore? Well, no, because then you would get the square root of 0, which is 0, and you would get a 0 in the denominator. So it's kind of like this problem plus this problem combined. So now when you have 1 over the square root of the absolute value of x minus 3, now it's no longer greater than or equal to 0. It's just greater than 0, right? It's just greater than 0, because we can't have a 0 here in the denominator. So if it's greater than 0, then we get rid of, then we just say greater than 3, and essentially you just get rid of the equal signs right here. Let me erase it properly. You get it's a slightly different color, but maybe you won't notice. So there you go. So that's actually, let me just do another example since we have time. Let's see. Let me erase this. Okay. Now let's say that my pen is, let's see. Oh, I'm using the wrong color, that's why. Let's say that oh, yeah, no, I know. Let's say that f of x is equal to 2 if x is even, and 1 over x minus 2 times x minus 1 if x is odd. So what's the domain here? What is a valid x I can put in here? So immediately we have two clauses. If x is even, we use this clause. So f of, oh man, my pen messed up again. So let's say that f of 4, well, that's just equal to 2 because we use this clause here. But this clause applies when x is odd. And just like we did in the last example, what are the situations where this kind of breaks down? Well, when the denominator is 0. Well, the denominator is 0 when x is equal to 2 or x is equal to 1, right? But this clause only applies when x is odd. So x is equal to 2 won't apply to this clause. So only x is equal to 1 would apply to this clause. So we can only have, so the domain is x is a member of the reals such that x does not equal 1. I think that's all the time I have for now. Have fun practicing these domain problems.